good evening, my dear students, or good morning whenever you are opening this video. I don't know which time you are opening it, so if it is in the morning, good morning. If it is now, good evening. I have just thought with a very simple idea to overcome the circumstances that we are living now, and that we are not able to talk face to face or to experience our material and deliver it with you as the normal way that we are using all the days before, which is face to face within the school. I have started to think about too many things. First of all, I've started thinking delivering the substance or the material that you are going to take with the handwriting. Then today I thought that handwriting is not more enough for some of you to understand, so I have just moved into the second step, which I think that it could be somehow more efficient than the old one, which is the handwriting that I sent. As you can see, it is a small whiteboard, and I'm trying just to give the material that you are or you have been taken in the last 3 weeks. I should give it for you in a simple way, a very simple way, just to give the ideas and to give the things that you are required to know, required to be asked about then or subjected within any exam. So let's go directly to the material that was given and start with something that some of you asked me within the inbox in the Edmodo about the oxidation of alcohol. Oxidation of alcohol, if we are going to start talking about oxidation of alcohols, we should first say that alcohols are classified into 3 main types, as you all know. The first one is the primary, and this part I think we have covered it within the school. The second one was the secondary, and the third one was the tertiary. We use simples to represent each type of these, like this one, 3, 2 for the secondary, 3 for the tertiary, and 1 for the primary. What is the difference between each of them? This is very important to know, because when you are going to talk about oxidation, you would find that not all of these kinds of alcohols are subjected to oxidation. Only 2 of them, which are the primary and secondary, are, while the third one is not. So this requires to know what's the difference between the 3 types. In the primary alcohol, any alcohol is classified as primary if the carbon atom, which is bonded directly to the OH group, which is the functional group in the alcohol. It is the functional group. We all know that the functional group within alcohol is the OH group, called hydroxyl group. Now, look at the carbon which holds the OH group. If you find it bonded to 2 hydrogen atoms and 1 carbon atom, so whatever number of carbon atoms in the compound, the most important carbon atom is the one that holds the OH. Look beside the OH, away from the OH group. What are other 3 bonds that are making the 4th bond of the carbon? You would find, if you find that 2 hydrogen atoms with 1 carbon atom, so directly it is primary. While in the secondary, what characterizes the secondary is that the alcoholic carbon, we call it alcoholic carbon, which means that the carbon that is directly bonded to OH. If you find beside the OH that you have 2 carbon atoms with 1 hydrogen atom, now the alcohol is classified to be secondary. While in this case, you will find that the 3 carbon atoms are surrounding the one which holds the OH, which is alcoholic carbon. If you find in any alcohol the carbon which holds OH is also bonded to 3 other carbons from 3 sides, so it is now tertiary. One example of each, I would put it here before I go into the oxidation. For example, this one, CH3, CH2, OH. If you make the structural formula for it, you would find it CH3, CH2, OH. This is the idea. The carbon here, which holds the OH, is directly bonded to 2 hydrogen atoms and 1 carbon, so it is now called what? Primary alcohol. For example, for this one, CH3, CHOH, CH3. Again, if you make the full displayed formula for this alcohol, you would find it like this way. Look at this carbon atom, which is the most important one, and you will find it bonded to carbon from one side, hydrogen from one side, and carbon, another carbon from the other side. So it is what? Now it is tertiary, sorry, secondary. Now let me go to the tertiary with one example. CH3, COH, CH3, CH2, CH3. I think if you make it full displayed, you would find it like this way. Look at this carbon atom. Look at this carbon atom, which is what? The one that holds the OH. You will find it bonded to carbon from one side, another carbon, and the third carbon here. So it is now called tertiary. So this is the first point that we should know before we go on into the oxidation, is that we have three types of alcohols: primary, secondary, tertiary. Now, going to the oxidation process itself, before we go into details of it, you should know very important things, which is what? Oxidation in organic compounds. Oxidation is gain of oxygen or loss of hydrogen, while reduction is gain of hydrogen or loss of oxygen. Why is that important? Because you would find the two things, gaining, losing oxygen, hydrogen, are you will find them in the oxidation process for the alcohols. So first of all, let's see the process of oxidizing primary alcohol. Primary alcohol, when you start with it and oxidize it using oxidizing agent, because any process of oxidation needs oxidizing agent, while reduction process needs reducing agent. In the first process, primary is being oxidized, giving aldehyde, while if the aldehyde stays in the container of the reaction with the presence also of the oxidizing agent, as we can say, the second step of the oxidizing primary alcohol. The second step is, the first one was primary to aldehyde. The second one, if the aldehyde stays in the container of the reaction, it would continue into what? Into carboxylic acid. How is that happening? Let's take the general formula. We have agreed upon that the primary alcohol should be like that. And don't be feeling strange when you see R here. R represents the hydrocarbon chain from this side or any other side. I don't care about. It means that here in this side you have carbon and hydrogen. Whatever the number of carbon and hydrogen, I don't care. We again emphasize on the most important part that makes the alcohol primary, which is that this one, which holds the OH, is bonded to 2 hydrogen atoms and 1 carbon from this side. R here means carbon with hydrogen. For oxidizing agent, if you want to use oxidizing agent, here we have too many oxidizing agents, but in your book, we are talking about only two of them, which are either K2, Cr2, O7, called potassium dichromate, in the presence of few drops of acid. That's why you sometimes find it in questions or in textbook, acidified potassium dichromate. This symbol, H plus, represents acid. So when you say acidified potassium dichromate, it means that the oxidizing agent is being added to the reaction in the presence of few drops of an acid. Or you shouldn't use the two of them, KMNO4, potassium manganate, also in the presence of few drops. Not both of them, you should use one of them. In this case, where is the oxidation? We said that the oxidation is either gain of oxygen or loss of hydrogen. Here the oxidation happens by losing hydrogen. Which two hydrogen to be lost? One of them is the OH hydrogen, and the other is one hydrogen from the same carbon atom. Look carefully. It is very important to know that the hydrogen to be lost is the hydrogen that is from the same carbon atom. But one of them from the OH and the other is one of these two free hydrogens. I mean, you can take this hydrogen. It's not supposed to be this one. Any hydrogen from the same carbon. If you lose these two, you would substitute the loss of bonds by what? By creating a double bond here. Double bond that's supposed, the double bond here supposed to substitute the two hydrogens here. And the hydrogen, this one, remains the same. Don't forget that this part is the functional group for what? For an aldehyde. If this one remains in the reaction with the presence of the same oxidizing agent, whether this or this, again, we don't use two of them, one of them. Now, the second oxidation process taking place by what? Gaining oxygen. We said that the first one was by losing hydrogen. Now, this one is going to take place by adding oxygen or gaining oxygen, like what? This is the R, C. This is the double bond that was created in the first step with O. Now, the new O here. The new O is here. This is the new O added. Look that this one is the functional group for what? It is the functional group for the carboxylic acid. So we can say that the primary alcohol undergoes two steps of oxidation. In the first step, it goes into aldehyde. In the second step, it goes into carboxylic acid. One small example, simple example, CH3, CH2, OH. When you use KMNO4 in the presence of acid, again, this is the important carbon that I'm talking about. I would take one hydrogen from here, because they are both at it, and one hydrogen from here. You are simply just do that. This carbon atom converted from one with alcohol to one with what? Aldehyde. Yani just copy this part as it is, CH3, without changing anything. Once you reach the carbon that it is the alcoholic one, convert it into the aldehyde one. This is what I do. Just write the functional group of the aldehyde on the carbon that was holding the OH. And if you want to continue this one with the presence of the same oxidizing agent, you should do what? Copy this part here, and once you reach the functional group, you change it into the functional group of a carboxylic acid. This is what happened here. This is what happened in the oxidizing of primary alcohol. So it is a matter of changing what? This part, change it into what? Into one that is what? Suitable with the functional group of aldehyde. And the same thing is do it as the functional group of the carboxylic acid. While this part which is the R here, here, here. The R is the same in all cases. Let's go to the secondary one and see what happens. If you bring secondary alcohol and use oxidizing agent, it would give ketone. And ketone goes no further oxidation. It is not like aldehyde. Aldehyde in the primary was going into new oxidation, giving what? Carboxylic. Ketone is not being oxidized, so the process will stop here at the ketone. It will not go further into new compound. For example, let me write it in the general formula. This is the general formula for a secondary alcohol. If you go back to the beginning of the video, we said that if the carbon that holds the OH is bonded to 2 carbons and 1 hydrogen, the carbons are represented by R chain here. It is secondary. What you should do only is what? The same thing, K2, Cr2, O7, or KMnO4. I don't care about which one. What should you do is only these 2 hydrogens should be removed. These 2 from the same carbon. So in a simple idea, you are changing this carbon atom into what? Into a new carbon atom that holds what? The double bond O. And I think in this case you are changing the secondary alcohol into what? Into a ketone, since this one is the functional group of a ketone. For example, CH3, CH2, CHOH, CH3. KMnO4 H plus, it would give you what? CH3, CH2. Now I reached this carbon. This is the R here, and this is the second R. This is the important part. I would change it into C double bond O, like that. Since it is secondary, it would give you a ketone, and continue with the other part. This is what you should do. Only write the 2R as they are, but once you reach the carbon atom with the OH, change it into C double bond O. So that's now you are writing the ketone. For the tertiary alcohol, there is a problem, which is what? If you look for the primary alcohol again, and the secondary, and the tertiary, you would find something clearly obvious. I think so. Which is what? In the oxidation here, we took this H with this H. Or we can use this one with this one, I don't care. In the secondary also, you take this hydrogen with this hydrogen when oxidizing the secondary. The problem with the tertiary is you have this hydrogen, but you don't have another free hydrogen on this carbon atom to be removed with it to oxidize it. That's why tertiary alcohol is not being oxidized. Tertiary alcohol not oxidized. Why is that? This is a normal question, because alcoholic carbon, you know what I mean by alcoholic carbon? This one, the one that holds OH. It is called alcoholic, to just distinguish it from all other carbon atoms. Because alcoholic carbon atom doesn't have free hydrogen atom. So only primary and the secondary are being oxidized, while the tertiary is not being oxidized. Because of that, this is the idea of oxidation of alcohol. Thank you for now. This is the first part. I would follow this video directly now with another video talking about polymers. But this, I should end this part now in order to start another one with the polymers. Polymers are going to be given to you in a special video along with this one, and it would be given to you directly, both of them, within one session. Thank you very much.